All right, well, greetings. My tone is a little off today. I'm a little sick, but that does not stop me, nor will it stop you from learning about graphing square roots. I'm excited, and I know you are. Here we go. We've had a discussion in class before. We want to make our lives easy, so we have to think, what's the smallest number allowed in a square root if we're dealing with real numbers? Can't be negative. So naturally, the smallest number is 0. So when you're looking at the inside of every square root, I want you thinking, what number will make the inside 0? Well, if we have x minus 1, what x value will create a 0 on the inside? 1, and that's where I start. Picking the x values is the most crucial part of graphing the square root. That is where I'm going to be starting. Now, be intelligent about this. We're taking square roots. So we want to find convenient insides. I want to have 0. Well, square root of 0 is 0. Think of another nice one. 1. Square root of 1 is 1. What about 2? If I get a 2 on the inside, square root of 2, yeah, I don't know either, because it's an infinite non-repeating decimal. So think of the next convenient number. 2 no, 3 no, 4. 4 is the next nicest perfect square. So when I pick my x values, I want to pick numbers that create a 0 on the inside, create a 1 on the inside, and then lastly create a 4 on the inside. So we already know what creates a 0. What number would x become to create 1? X would have to be 2. Think about it. 2 minus 1, that's where we get our 1. And so to get a 4 in here, I would need 5. So that is how I come up with my x values before I start. Now I'm just evaluating. 1 minus 1 is 0, square root of 0, 0. 2 minus 1, 1, square root of 1, 1. 5 minus 1 is 4, square root of 4, 2. So it's pretty simple evaluating after that. Now we plot our points. At 1, 0 is where it starts. It starts. Now, from here, I just plot my next 2 points. 2, 1, and 5, 2. Now, this is going to give you a general idea of the curve of it. Now, keep in mind, though, this is only going to have one arrow. It goes infinite in one direction. It can't go 2. It starts here and goes off. It does not go to the left because we already established the smallest number allowed in here is 0. Well, if I picked a number to the left of 1, that would create a 0 on the inside, which would not be allowed. So that is a quick way how to graph a square root function. What if we have an inequality? It doesn't change our approach until the very end, okay? So look only at the guts. I know there's a lot more going on here, which could happen, okay? But it doesn't change my approach. I still only look at the inside. X plus 3. Remember, I want a 0, I want a 1, and I want a 4. So what will make x plus 3 equal 0? Negative 3, right? It's just what adds to 0, okay? So what will we have to make x to add to 1? Negative 2. What will we have to add to 3 to make it 4? 1. Again, this is the most crucial part of the entire process. If you pick the wrong numbers, it's all going to be wrong. If you pick the right ones, you got a shot. Evaluation time. PEMDAS. Make sure you follow order of operations. Negative 3 plus 3 is 0. Square root of 0 is 0. Times negative 2, 0, minus 1, we get a negative 1. So that's where I'm starting, or our vertex. Plug negative 2. Negative 2 plus 3, 1. Square root of 1, 1. Times negative 2, negative 2, minus 1, negative 3. Now, I know I'm going through that quickly. If you need to take a little more time when you're doing your homework, feel free to do so. But we're going to continue going about that speed. 1 plus 3 is 4. Square root of 4 is 2. Times negative 2 is negative 4. Minus 1 is negative 5. So these are my 3 points right now. Now you'll notice this one has a bit more transformation behind it. We don't speak in length of transformations, but we're going to be stretched by 2. It's negative, so we're going to be flipped over the x-axis. A plus 3 means we're going to move left 3, and a negative 1 on the outside means we're going to be down 1. Let's see if it actually backs up our points. Negative 3, negative 1. Well, right away, this point from the origin went left 3, down 1. It's exactly what I claimed. I'm not a liar. -2, -3. Hey, it's starting to go down, meaning we are going to curve down. Told you I wasn't a liar. Lastly, 1, -5. Ooh, that's a big jump. It's almost as if it was stretched, which is what I said was going to happen anyways. So your points should back up what you think the transformation should look like. Pause. This is an inequality. So this is not the same process. You don't just draw the curve. Inequalities. This is less than. It is not equal to. Therefore, it is going to be a dotted line. If it was equal to, then I would have a solid line. Remember, dotted means it does not include in this final answer. Solid line means it does include. Remember my rule, if you see a line, be a line, okay? Now, 2 things when we go to shade. First off, same principle that's going on here, how we don't have an arrow going left. I don't have anything going left, because if I did, that would make a negative on the inside. So you almost have to think, there's this imaginary wall that nothing can go left of. I guess it's not imaginary, it's real. You can't go past that. So when I pick a point to test, it has to be clearly above the curve or below the curve. Now, most of you are big fans of picking 0, 0. That's clearly above my curve. So I'm going to plug that into my original inequality and see if it makes a true or false statement. Plugging in 0, 0, which means 0 becomes my y, and 0 becomes my x. Now, we arrive at 0 less than -2 times the square root of 3 minus 1. Now here's something, I don't have a calculator, but I am a pretty logical being. Let's just use logic. -2 times square root 3. That's going to be a negative number. Then I'm going to subtract 1 from it. It's going to become a larger negative number. So can we conclude that this right side will be negative, right? It will be negative. The left side's 0. So this is saying 0 is less than a negative number. Think about that. Is 0 less than a negative number? No. So I picked a point that was above, and above turned out false, which means below is true, and that is where I shade. Notice I do not shade past the imaginary wall. Quick tutorial on graphing inequalities with a table and how to approach an inequality when it came to shading as well. Hopefully it helped. Hopefully next time I have a better voice.